Okay, Professor Gish here. In Blackboard, I have a post where I do a partial fractions decomposition or partial decomposition of fractions. I do it with 3 different methods, and I believe we had some linear and repeated linear factors in that example. So I wanted to do one with an irreducible. So let's do an irreducible in this video, and then hopefully between the example I posted and then this video here, hopefully kind of get you squared away on all the different possibilities we're kind of dealing with. All right, so let's do it. First of all, this is a linear factor. Oops. There we go. This is a linear factor, and it is got a power on it, so we're going to have to repeat that. So that tells me this whole thing would be equal to a over x plus b over x squared, right? Okay, now this one is an irreducible quadratic. And just to make sure we're all on the same page, remember, what do we mean by irreducible? Well, if I set that equal to 0 and solve, right, I'd have to take square root of -1, which is not a real number. In other words, there are no real factors or real solutions, so I cannot factor this with real numbers. I cannot reduce it into factors with real numbers, so it's irreducible. All right, and this also has a power on it, so we're going to have to build it up. So when you have irreducible quadratics, up top it's a linear factor. Okay? And then I'm going to build this one up because, again, there was a power there. And this is a different linear factor, right? So right there, that's half the battle. If you can get this all kind of laid out correctly, then you're kind of well on your way, right? And so we did that. And so now what? Well, I have sort of, think of this as like the left-hand side of my equation, right? That's equal to what I just wrote on the right. I want to get rid of all of the denominators. So I'm going to multiply everything times x squared plus 1 squared. And I'm going to do the same thing over here. Don't mind, I don't know if you can hear the background, it's just my kids. So, alright, so let's do it. Alright, so we'll now work this out. And so the a's cancel, or not the a, the x, and one of those x's cancels. So I have ax times x squared plus 1 squared. The x squareds and the x squareds canceled, so I have b times x squared plus 1 quantity squared. Now, it's cx plus d, that whole numerator, that whole linear factor, so make sure you put it in parentheses. A lot of times students forget to put that in parentheses, and so then they forget to distribute because they forgot their parentheses, and that messes them up, so don't make that mistake. But that's going to cancel with one of those x squared plus 1 factors, and then plus, again, ex plus f, again, to make sure that linear factor is in parentheses. But the irreducibles are going to completely cancel, and so that leaves me with just an x squared. So let's just look at that real quick. We want to make sure we didn't make any mistakes, because if we make a mistake here, that's just going to carry through all the rest of our work. So I'm just going to do a quick glance, double check it. I feel pretty good about it. Yep, feel good. All right, so now it's time to expand. Before we expand, though, let's do a little scratch work on the side. So x squared plus 1 quantity squared. What is that? That is x to the fourth. That would be plus 2x squared plus 1. Okay? So, just want to keep that in mind because we're going to use that. Alright, looks good. So let's see here. So scratch work. This is going to be what? Well, this is now x to the fourth plus 2x squared plus 1. So if I distribute that, and it is still distributing, that's still in parentheses, right? That becomes ax to the fifth. That'd be plus 2ax cubed plus ax. Okay. This is what? Well, again, it's what, x to the fourth plus 2x squared plus 1. So again, let's distribute. So that's now bx to the fourth plus 2x. Don't forget your b there. Plus 2bx squared plus b. Good. This x squared I'm going to distribute into here, so that gives me x to the fourth plus x squared. And then now I can distribute that linear. So I'm going to distribute the cx first, so plus cx to the fifth. Cx times x squared is cx cubed. Dx to the fourth. Dx squared. And then the last part, ex cubed plus fx squared. All right, so I feel pretty good about that. And now I'm just going to reorganize everything by powers. And so that is what? That is ax to the fifth plus cx to the fifth. Now let's do my fourth powers. So bx to the fourth plus dx to the fourth. Looks like it. It's not a terrible idea either to check things off as you go. And our third powers, we have a 2ax cubed. Looks like cx cubed and an ex cubed. And then squares, 2bx squared and plus dx squared plus fx squared. Again, just not a terrible idea. And then, is it just an ax? It looks like just an ax. And then a b. So now I'm going to rewrite everything by just kind of pulling it apart. So ax, oops, there's 2x to the fifth parts there, so a plus c x to the fifth plus b plus d x to the fourth plus 2a plus c plus e x cubed plus, let's see here, that would be 2b plus d plus f x squared plus ax plus b. Now this is good because if I go to my original, I guess I'll do it in red maybe. My original is what? Ax to the 5th minus 5x to the 4th plus 14x cubed minus 4x squared plus 5x minus 3. And so I can match those constants up with those coefficients, and they should be equal. The left and the right side should be equal. So for example, I get a couple things for free right away. And so, like here, that tells me A is 5. And similarly, that tells me if the left and the right hand sides are equal, then B has to be -3. Oh, this is great, because now I can start just knocking things down. A plus C, let's see here. I'm going to try to be a little bit more organized about this, though. A plus C is 8 from the x to the 5th term, but we just saw that what? We just saw that A is 5. So that means 5 plus C is 8, which tells me that what? If I subtract 5, that tells me that C is 3. Okay. Next. Oh, hey. B plus D is -5. But we know that B is what? -3. So -3 plus D is -5. So if I add 3, then that is -2. So D is -2. So this is working out rather nicely here. Now what? Let's work on that 14. So 2A plus C plus E is equal to 14. But we know what, friends? We know A is 5. We know C is 3 now. And E, well, I can find that now pretty easily. So that's 10, 13. So if I subtract 13 over, that tells me that E is 1. And last but not least, 2B plus D plus, there we go, plus F is equal to -4. So just subbing things in, B was -3. We know D now is -2. F, I don't know, but I'll find it now. That's -6, -8. So I would add 8 over -4 plus 8 is +4. So looks like F is +4. Therefore, my decomposition is what? So it's A over X. So 5 over X. Nope, not plus, because B is negative. So minus 3 over x squared plus cx plus d, but d is -2 over x squared plus 1 plus ex, e is 1, plus f over x squared plus 1 squared. And there you have it. So that one worked out pretty well, and that's kind of the technique I like to use, but you could certainly use other ones. There's kind of lots of ways you can tackle these. You can do systems of equations, you can do matrices, you can do all sorts of stuff. You can do the substitution thing. But I like to match the coefficients up and then just chip away at it as much as I can until I have to have a system. So this time, in this case, I didn't even need a system. So, all right. Okay, friends. Well, I hope that was helpful, and yeah, didn't even need a calculator. All right.